So now we are going to find the electric field due to an electric dipole on the equatorial line, okay, at a point on the equatorial line. So we first consider an electric dipole. So we have here an electric dipole minus and a plus charge, a negative and a plus charge. So we have an electric dipole minus q plus q. They are separated by a finite distance apart. Now let this minus q be at A and plus q be at B, and let O be the center of the electric dipole. Now the distance of charge minus q from O is given by small letter A. Similarly, the distance of plus q from the center is again A. So dipole length is 2A. Now an equatorial line is a line which passes through the center of the dipole and is perpendicular to the dipole axis. So this is the equatorial line. It's a line passing through the center of the dipole and it's perpendicular to the dipole axis. Now let us find the electric field at this point P due to this electric dipole. Now the electric field at point P will be due to charge minus q and due to charge plus q. So we have here the distance of this charge minus q from point P is this AP, and the distance of this point P from the charge plus q is PB. So now the electric field due to the charge minus q is given by EA, and this is equal to 1 by 4 pi epsilon naught q divided by the square of the distance of the point P from the charge minus q, and this distance is PA. So here we have q by PA square. Now if we look at the diagram, that is in triangle PAO, then what we have is this in triangle PAO. PA is the hypotenuse, OA is the base, and OP is the perpendicular. So in triangle APO, we have the square of the hypotenuse, which is PA square. This is equal to the square of the base OA and the square plus the square of the base OP, of the perpendicular OP. So here we have PA square to be equal to OA square plus OP square, and OA is equal to A. So here we have PA square is equal to A square, and OP is equal to, say, X. So we have OP to be equal to X. So we have PA square is equal to A square plus X square. So your EA is equal to 1 by 4 pi epsilon naught, then Q. So instead of PA square, I'll write A square plus X square. So this is the magnitude of the electric field at point P due to the charge placed at A, that is due to the negative charge minus Q. Now electric field is a vector quantity, so it has a direction. So in order to find the direction of the electric field EA, we'll have to make use of the concept of electric field lines. And according to the properties of electric field lines, for a negative charge, the electric field line is directed towards the negative charge. So in this case, EA, okay, will be directed towards the negative charge minus Q. So the electric field at point P due to due to the charge at A, is directed towards the negative charge. So here we have P is there. The electric field EA is directed from P to A. So now the electric field intensity due to the charge plus Q at P. Now this electric field due to plus Q, which is placed at B, is given by EB, which is equal to, then we have 1 by 4 pi epsilon naught, then Q divided by the square of the distance of the point P from the charge plus Q, which is PB. So here we have distance PB square. And again, if you look at the diagram and this triangle POB or BPO, then in this triangle BPO, what we have is the hypotenuse. The square of the hypotenuse PB square is equal to the sum of the square of the base OB plus the perpendicular OP square. So here we have PB square to be equal to AA square plus X square. So we have 1 by 4 pi epsilon naught, your EB to be equal to 1 by 4 pi epsilon naught Q. Then instead of PB square, I'll write A square plus X square. Now this is equal to the magnitude of the electric field due to the charge at A. So your EB will be equal in magnitude to EA, only in magnitude. Now the direction is different for the two electric field. For EA, we know it's directed towards the negative charge minus Q. Now for EB, again we have to use the concept of electric field lines. According to the properties of the electric field lines, for positive charge, the electric field is directed away from it. So for positive charge, the electric field is directed away. So for EB, the direction will be away from the positive charge, or in the direction BP. So this is the direction of the electric field EB, away from the positive charge. Now these are two vector quantities, EA and EB. If we want to find the resultant vector or the resultant electric field, then we'll have to use the vector law of addition. We have two laws of addition. One is triangle law and one is parallelogram law of vector addition. So here we are going to use the parallelogram law of vector addition. So first what I'll do is I'll draw a parallel line, a line which is parallel to the dipole axis, and let this PAO be theta. The angle PO is theta. So we have this angle here to be also equal to theta. Then we have again PBA, the angle PBA is equal to theta. They are equal since they are equilateral triangle, and this angle here is also equal to theta. Now what we'll do is we'll draw a parallelogram using the sides EA and EB. Using the two vectors EA and EB, we draw a parallelogram. Now according to the Parallelogram law of vector addition, the resultant electric field intensity is given by the diagonal of the parallelogram. So this is the resultant electric field intensity. It's given as E vector. Okay, so this is the diagonal of the parallelogram. Hence, that is the resultant electric field intensity. Now, if we can recall the parallelogram law of vector addition, if we have two vectors acting at a point, say one vector is A and another vector is B, they're acting at the same point, then the resultant is given by the diagonal of the parallelogram. So this is the resultant vector, or by using the parallelogram law of vector addition. So the magnitude of this resultant can be found out, or is given so first what we'll do is let this angle be alpha, the angle between the vector A and the vector B. Now the magnitude R, this is equal to the square of the magnitude A plus the square of the magnitude B, then plus we have 2, then A into B, then cos of the angle between the two vectors A and B, which is alpha. So this is the magnitude of the resultant R, root over A square plus B square plus 2AB cos alpha. Similarly here also, the magnitude or the resultant vector quantity E in magnitude, this is equal to root, then we have E A square and plus EB square, there's the magnitude, then plus 2 the magnitude EA into EB, then cos of the angle between the two vectors EA and EB. And here the angle is this, here we have theta plus theta, theta plus theta is equal to 2 theta. So the angle between them is 2 theta. Now this EA is actually equal to EB. We have shown that earlier. Your EA is equal to EB. So here, instead of EB, I can write EA. So first we have EA square root square root EA square plus instead of EB, I'll write EA square, then plus 2 EA. Instead of EB, I'll write EA. We have cos 2 theta. Then here EA plus EA will give you 2 EA square. So here we have root 2EA square, then plus again here EA to E into A is EA into EA will give you EA square. So here we have 2 EA into EA square. So cos 2 theta. Now we take common these 2 EA square. So what we'll have is so upon taking common 2 EA square, we have 1 into 1 plus cos 2 theta. So we have E is equal to root 2EA square into 1 plus cos 2 theta. Now we'll have to use the trigonometric expression for this cos 2 theta. So if we can recall the or from mathematical formula, cos 2 theta is equal to 2 cos square theta minus 1. Now we'll bring this minus 1 to the other side, it will become plus. So we have 1 plus cos 2 theta, this is equal to 2, then cos square theta. So here we have 1 plus cos 2 theta, this is equal to 2 cos square theta using the trigonometric expression. So 1 plus cos 2 theta, you can see here 1 plus cos 2 theta is equal to 2 cos square theta. So instead of 1 plus cos 2 theta here, I'll put with this one, 2 cos square theta. So your E is equal to, so we have 2 EA square, then instead of 1 plus cos theta, I'll write 2 cos square theta. So now this square root will cancel the 1 2 here and 1 EA square and cos 1 cos here. So we have 1 2 is cancelled, then the 1 EA is cancelled, and 1 cos theta is cancelled. So what we have is 2 EA, then cos theta. So E is equal to 2 EA cos theta. Now cos theta, you can find the expression for this cos theta using the diagram above. So here we consider the triangle POB. Now in this triangle, your OB is the base and PB is the hypotenuse. So cos theta is base, which is OB. This OB is A. So cos theta is equal to A divided by the hypotenuse, which is PB. Now PB, we have done this hypotenuse before. We have found the expression for the square of the hypotenuse PB square. So your PB square, this is equal to OB, or simply A square plus X square. This we have done before. Now taking root what we have is PB will be equal to square root of a square plus x square. So here we have square root a square plus x square. So this is your cos theta is equal to a divided by root over a square plus x square. So instead of cos theta, I'll put the value this one here. So cos theta will be equal to a root over a square plus x square. Now for EA also, we have found the expression before. Now this EA is equal to 1 by 4 pi epsilon naught q divided by a square plus x square. So instead of EA here, I'll write this one 1 by 4 pi epsilon naught q divided by a square plus x square. So the expression for E now becomes 2. Now EA is 1 by 4 pi epsilon naught then q divided by a square plus x square, and cos theta is a divided by root over this a square plus x square, or we can write the square root as half, a square plus x square to the power half. Now this 2, I'll keep it here. Then if you can recall, q into 2a is your dipole moment P, okay, electric dipole moment P. So q into 2a, this will give you small p. So q to a will give you this p, small p, the dipole moment. Now a square plus x square is to the power 1. Then here a plus x square again, this is the power half. So here we can add 1 plus this half. So the expression will now become this 1 by 4 pi epsilon naught p, then a square plus x square 1 plus half. Now 1 plus half, if you add this, you'll get 3 by 2. So your expression will now be 1 by 4 pi epsilon naught, then the p, then we have a square plus x square to the power 3 by 2. This is from adding 1 and half. So this is the expression for the electric field intensity at point P on the equatorial line due to the electric dipole, and it is given as 1. Your E is equal to 1 by 4 pi epsilon naught P, the dipole moment, divided by a square plus x square holding or to the power 3 by 2. Now electric field is a vector quantity, so we can express this in the vector form also. So in vector form, if you look at the diagram, now your E is in this direction. Now P vector is from minus q to plus q. So here your P, your dipole moment P vector, It is directed from minus q to plus q. So in this, it is in this direction, and you can see that E is opposite to P. So E is in this direction and your P is in the opposite direction. So in vector form you have E vector, then I'll put minus, then you have P vector. This minus indicates that E is opposite to P. Okay, so look at the diagram. Again, here we have E is opposite to P. So here we have E is opposite to P. So the negative sign indicates that your electric field intensity is opposite to the electric dipole moment. So for a short dipole, your A is very small, the dipole length to A. So A is very small as compared to the distance x. This is only for a short dipole. So we can neglect A in this expression. So we'll neglect this A square in the expression. So what we'll have is just x square to the power 3 by 2. So here x square, then we have 3 into 3 by 2. So 2 and 2 cancel. So what we have is x cube, x to the power 3. So the expression for a short dipole will be 1 by 4 minus 1 by 4 pi epsilon naught p vector divided by x cubed. So this is the expression for a short dipole. Now this is in vector form. Now we can write just the magnitude also. In the magnitude, you can simply write E is equal to 1 by 4 pi epsilon naught p divided by x cubed without the minus sign.